now that we have an idea of how to actually get the terms given a recursive rule, let's talk about how we can actually write recursive equations and rules. So just like before we learned about the arithmetic sequence and the geometric sequence, the recursive equations are quite simple, actually. So for the arithmetic sequence, we're still using our common difference. So we have a sub n is equal to a sub n minus 1 plus d, our common difference. The only other information that we need is our first term of the sequence. So in this equation, the only thing we're really plugging in is d. A sub n and a sub n minus 1 stay as is. And we just find our common difference. And then we write our first term. So a sub 1 equals whatever our first term is. For a geometric sequence, it's very similar. We have a sub n is equal to r, our common ratio, times a sub n minus 1, comma, a sub 1 equals whatever our first term is. And again, in the here, all we're really plugging in is our common ratio. So if we're given a sequence, like a list of numbers, we need to determine whether it's arithmetic or geometric, and then use the correct equation. So when we take a look here, we want to write our recursive rule. Over here, we have 3, 13, 23, 33, 43. If we take a look at this, at the pattern, you want to notice if it's going by like adding or subtracting by a same quantity, then you want to check to see if it's arithmetic. If it looks like it's growing or getting smaller at a very rapid rate, then you might want to check geometric. Either way, you could always check both. There's nothing wrong with that. But over here, I'm seeing 3 to 13, 13 to 23, 23 to 33. I'm seeing an increase of 10. So I can go ahead and I can try to find my common difference. And noticing first off that my a sub 1 is 3. So my very first term of my sequence is 3. I'm going to need that for later. And then I want to then go ahead and find my common difference and confirm that it is arithmetic. So second minus first, so 13 minus 3 is 10. 23 minus 13 is 10. 33 minus 23 is 10. So essentially our common difference d is 10. So we take our arithmetic sequence here because we have that common difference. And all we're going to do is we're going to write a sub n is equal to a sub n minus 1 plus our common difference 10, comma, our first term. So a sub 1 is equal to 3. And that's your recursive rule. That's it. That's all you need. Okay. As far as our next example goes, I have 16, 40, 100, 250, 625. 16 to 40 and then 100 to 40, that's too big of a gap to be something that we're adding or subtracting by. So we might want to check to see if it's geometric. First things first, notice our first term here is 16. So we want to definitely notice that. And then we want to see if this is actually geometric by doing the common ratio. So we'll do 40 over 16. And see what that brings us. So 40 over 16 is 2.5. 100 over 40 is 2.5. 250 over 100 would be 2.5. So our common ratio here would be 2.5. So then, since we have a common ratio, we have a geometric sequence here. So we're going to have a sub n is equal to our common ratio 2.5 times a sub n minus 1. So we have a sub n is equal to 2.5 times a sub n minus 1, comma, our first term, a sub 1 equals 16. Okay. So you can go ahead and you can try working on these. Go ahead and pause the video so that you can actually try to work these out and see if you can write them in the recursive equation for arithmetic or geometric. Okay, good job for trying. If you want to check your answers, here we go. Our first one was a geometric. So we should have 7 times a sub n minus 1. And our second one here was arithmetic with a common difference of 6. If you want to see the work on how to obtain our common ratio and our common difference, here it is. Okay, it's literally just identifying your first term and then the common difference or the common ratio and plugging it in. That's really all there is to it. Okay, so that's if you're given an actual sequence, a list of numbers. If you're given an explicit formula and asked to rewrite it in its recursive form, again, it's actually quite simple. You just need to remember the fact that an arithmetic and an arithmetic sequence actually contains your common difference. It contains your D, and it's always the number that's next to the N. Okay, so if we take a look here, we have a sub n is equal to -6 plus 8n. Well, the 8 here that's being multiplied to the n, that's actually our common difference. So that's our D equals 8. We have that. Now, what we don't have here is our first term, our a sub 1, and that's quite easy to find. You just plug in 1 for n and simplify. So if I plug in 1 for n and find a sub 1, I get that -6 plus 8 times 1 is just going to be positive 2, because -6 plus 8 is positive 2. So that means our a sub 1 is equal to 2, our D is equal to 8, and then we take it back to our recursive equation, which is simply that a sub n is equal to a sub n minus 1 plus 8, our D, comma, a sub 1 equals 2, our first term. If it's geometric, it actually makes it a lot easier, because geometric, if you remember, actually contains our first term and our common ratio. So we have all the information that we need in our geometric explicit form. So all I have to do is identify. A sub 1 is -3. My common ratio is 1/2. And then I just plug it into my recursive formula. So a sub n is equal to my common ratio 1/2 times a sub n minus 1, comma, a sub 1 is equal to -3 for our first term. Go ahead and try it yourself. You really want to pay attention to the differences between an arithmetic and a geometric and seeing what those differences are. I think they're pretty clear, but I want you to notice them yourself. Okay, we're adding or subtracting by a number times n. We have an exponent of n minus 1. I mean, they're pretty clear. So go ahead and try those out. Pause it. Try them out. Good job. So here you go. Check your answers, if you will. Okay, and if you need to see the process for them, they're quite simple. There's not really much calculations. It's just identifying parts, really. You do have an exit slip, and there will be a Google form for you to actually check your answers and input and see how well you did on this. Okay, good job, guys. I will be coming out with your chapter 9 material soon, and we will start learning about trigonometry soon. So, yay us. Good luck. Stay safe, stay healthy, and I'll talk to you guys later.